Welcome to Math 1300, Nunez Community College. Today we'll be doing section 2.2, which is the rectangular coordinate system. We are going to find the distance between 2 points that are on the rectangular coordinate system. If it was vertical or horizontal, we can just count the points. But if we have a point or 2 points that are in a diagonal direction, we have to come up with a formula, which they have, called the distance formula. The distance formula basically takes this and breaks it into a right triangle and uses the Pythagorean theorem in order to find the hypotenuse, which is what we're trying to find. So we'll label our points as P and Q, and P has an ordered pair, X and Y. Since it's the first point, we'll name it point 1, which is X1 and Y1. Q being the second point, we'll name it X2 and Y2. The distance formula, again, I said was derived from the Pythagorean theorem, and the distance formula is going to be the square root of X2 minus X1 squared. So it's the difference of the X coordinates plus the difference of the Y coordinates, which would be Y2 minus Y1 squared. Now, in the first example, it says find the distance between the 2 points, and they give us that P is -1, P is -1, -2, and Q is going to be -7, 8. So what we want to do is, we know this is our 1s, that's our 2s, we plug them into the formula and we simplify. So we have the distance is equal to the square root of X2, which in this case happens to be -7, minus X1, but minus a negative is plus. So minus a negative is plus. So it's -7 plus 1 squared plus Y2. Y2 happens to be 8 minus -2, which is plus 2 squared. And now all we do is do the operations and simplify. So this gives me the square root of -6 squared plus 10 squared, which is the square root of 36 plus 100, or the square root of 136. Now 136 may or may not break down. In order to do that, it's a square root. In order to take something from out of the square root, we need 2 numbers, squared meaning 2. 2 numbers that are the same to take one out. So I look at 136 and I try to find its prime factors. So the smallest prime factor I can pull out is a 2 because it's an even number, and 2 and 68, 2 times 68 is 136. And then we can pull a 2 out and we get what, 34. I can pull another 2 out and I'll get what, 17. I can see that this is a prime number, so it can't go any lower. Well, we have 2 2's, so I can take a 2 out. This is what's left. I don't have anything else to pair it to, so 2 times 17 is 34. 34 has to remain under the radical. So this distance is going to be 2 times the square root of 34. That is the distance formula. It's a formula you just have to memorize, and you can plug it in order to find the distance from one point to the next. Example number 2 that we have is finding the midpoint. So now we want to find the point in the middle. The midpoint. Well, the midpoint is going to be halfway between the 2 x's. And the midpoint is going to be halfway between the 2 y's. Halfway we think of as the average. We think of as the average. So if it says the midpoint formula, it's the average, and it's going to have to be an x and a y number, or an x and a y coordinate. So the midpoint formula is the average of the x's, which is x2 plus x1 over 2, comma, the average of the y's, y1 plus y2 over 2. So all we do now is we just add the numbers and divide by 2. So if they give us the same ordered pair, the same ordered pairs, but they say find the midpoint, we are going to plug it in as -1, x1, plus -7 over 2, comma, y1, which is -2, plus 8 over 2. This is the average of the x's, that's the average of the y's. This would be what? -8 over 2, comma, 6 over 2. -8 over 2 is -4, and 6 over 2 is 3. So the midpoint of this particular segment, if these were our endpoints, is -4, comma 3. And that's how you find the midpoint. This concludes section 2.2 on the coordinate system. I will see you at the next one.